Hello there, everyone at home. Here is your warm up. Where did it go? Is that there? It is. Okay, perfect. Get a full sheet of graph paper and a ruler from table. Well, you guys can't really do that if you're not here. Then make it a coordinate plane going 12 each direction. Also, there should be a little period here. There you go. Then make a coordinate plane going 12 each direction. Finally, graph Lena onto it according to these coordinates. There it is. You're going to want to have it look like this. So pause the video, graph that, and it should look something like this. How many of us are able to get this figure onto our coordinate plane or see how we got there? You guys doing okay out there? Cool. Did I mess up somewhere? Hold on. Let me see here. So negative 6 comma 4 negative. Oh, you know what I did? I see exactly what I did. Negative 4 comma negative 8 should be down here. That's what I did. So that's okay. It happens. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. There we go. That's right. Now we're talking. So it should be L I N A. Is that what you guys got right there? That looks better. Whew. Thank you. It happens. Huzzah. Okay. There's Lena right there. So let's figure out what we're going to do with her here. So it is the 122nd day of school. You know 122 is a semi-prime? A semi-prime is a number that has exactly two prime factors. And 122 is one of them because it is 2 times 61, which are both prime. It's National Poutine Day. Yay! Does anyone know what that is? Anyone know what that is? James does. Go ahead. Yeah, it's fries covered in gravy, which, guys, I know. You know what? Here's the thing. It sounds gross until you think about it. Then you're like, maybe it's delicious, and it turns out it is delicious. It's so good. You do wait? Did you say you don't like it, Arden?
No, I said it's really good.
It's really good. You got to put some cheese curds on there too. Put a little some cheese curds. It's so good. Yeah, Gracie.
Well, so on this podcast I listen to, the host is like Canadian, and I think he's like
It is definitely Canadian.
yeah. Well, he described poutine as a delicious mix of all the leftovers in the fridge.
Yep, absolutely. Let's see here. So I'm going to write down the coordinates of Lena because I totally forgot
The only
to.
reason I remember what it was is because it had a really funny name, and he
It does have a funny name, but it is delicious. So that's negative 6 comma 4.
Hey, having funny names is like better because
Negative, was that negative 4 comma negative 8? Yeah, absolutely. Oh, if there used to be this hot dog place that served poutine, and I miss it so much. 1, 2, 3, 4.
it's not served that much.
6 comma negative, is it 6 comma negative 6? Perfect. Gesundheit. And then A was 0 comma 0. Right? We're good. Awesome. Hooray. Okay. Let's get to it, guys. What is our first essential question? And I would love to get that from Ellie R. Awesome. Let's see here. Yeah, Stephen. And it's positive 6 comma 6. Thank you very much. Great question. Was that what you were going to say over here as well? Thanks, Ethan. All right, so I'm going to write down the essential question, which what are dilations? What are dilations? And how, I should say, how do they affect? Gross. How do they affect figures on the coordinate plane? Okay. Jeopardy, that's not the capital. Believe it or not, outside the U.S., people don't know Washington, D.C. is our capital and think it is this city, which is named after the state it's also not the capital of. That would be Albany. Gesundheit. That is indeed New York. New York, turns out if you ask people in Europe or Asia or Africa, it's like, what's the capital of the United States? They're like, New York?
Because that's probably the most famous city in the
Uh,
United States.
and then woodworking tools. Does anyone know what I'm trying to draw here? Yeah, Bradley. Close. You're on the right track. So a clamp is like something that you just have free floating, and then this is something that's actually affixed to a table. Starts with a V. It's a vice. A vice. A vice. Okay, let's see here, guys. Let's get to it. So, somewhere around this figure, got a pencil? Dilations. Dilations. So here's the funny thing about dilations, guys. Well, first of all, where have you guys seen the word dilation just floating around in the real world? When I say teach, I want you to say, okay, talk to your partners. Where have you seen that word and what does it mean? Teach! Kaylee Jane. Lou. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Where have you guys seen the word dilation before by raising a hand? I saw a couple hands go up. Elizabeth, what does that mean? Yeah, like it makes your pupils dilate, right? Which means that they get really big, right? Like you get giant pupils and you have to wear sunglasses because it's letting too much light in. Another thing is, but dilation isn't just getting bigger, because you know when they're in a TV show and someone's dead, there's a few ways, or there's someone lying on the ground and they want to find out if they're dead. There's a bunch of ways they check. What are some of the ways they check? What are some of the ways they check? Sadie. Yeah, they check their pulse. What else do they do? They check. They do a bunch of stuff on TV. They do so many things. What else do they do? Yeah, Carol. They open their eyes and shine a light in them, and that's the one I'm looking for. Because if you're dead and you shine a light into someone's eye, it's not going to do anything. But if you're alive, your eyeball is going to be like, ah, and like try to shrink because it doesn't want all that light shining in its eyes or in itself because it's your eyes. It's the same reason that if you have ever had this happen where you wake up in the middle of the night and it's totally dark and you like stumble to the bathroom, you have to go use the restroom, and like you're like I can't see anything, and then you switch on the lights and you're like, ah! Like it feels like 1,000 knives are going into your eyeballs. How many of us know what I'm talking about? Like, yeah, I hate that. I hate that. So a dilation is just a change in size, but very importantly, a dilation is not going to change the shape. Guys, our eyes are not like cat's eyes, right? Like when a cat's eyes dilate, is it the same shape? Like if you shine a cat, yeah, like if you're a person, yeah, if you're a person and like your eye dilates, what'll happen is it'll look something like this. Right? It just your pupil constricts or enlarges. But a cat is different. A cat, if a cat's excited and has big eyeballs because they see something they really want to see, like in their pupils, their eyes dilate like this instead. They like shrink into the middle like that, but they stay more or less the same up and down. So like if your kitty's relaxed, it looks like this, but if your kitty's really excited, it looks like that. So here's the thing. It turns out there's actually, do you know how in math it's like I say, hey guys, here's what we're going to be doing today, and you're like, aha, I think I already have an idea of how that will be done. And then I'm like, that would be cool, wouldn't it? But that's not how it works. How many of us know that feeling, right? Like especially in math, where it's like, that would be awesome if we could do that, but we can't. Why not? Now I'm like, oh, you're gonna have to wait for math 10, and then you can figure it out. But here's the thing: if I wanted to make Lena half the size, half the size, the thing that you're really hoping I can do to the coordinates right now is actually going to work. So when I say teach, I want you to say, okay, what do you really hope we can just do to these coordinates to get Lena half the size? Give it a try and teach. Hello, you got it all? Hooray. Will you open your Chromebook and go to Drive and find the thing I've shared with you there? Beautiful. I'll show you what we're up to. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1. Truman, can you tell me what you really, really hope we can do with the coordinates of Lena to turn it into half the size? Yes, exactly. And I love that you said have them, because what I want to know is that a lot of people said divide by 2, which is correct, but actually more technically we're multiplying it by a half. So if we took all of these coordinates and multiplied them by a half, that would turn Lena into L prime negative 3 comma 2. Yep, go ahead and write that down. I prime at negative 2 comma negative 4. N prime at 3 comma negative 3. And A prime at 0 comma 0. And so L prime would be negative 3 comma 2. I prime would be negative 2 comma negative 4. N prime would be at 3 comma negative 3. And A prime's at 0 comma 0. Gesundheit. So is Lena prime. It would be. It would be. But it would also still be A prime. It would also say it would be A and A prime. It hasn't moved, but you would also still think of that as moving to itself. Because otherwise we got a figure called L prime, I prime, N prime, A, right? And that just makes it sound too much like it's Dr. Seuss. We've got L prime, I prime, N prime, A. Why'd the prime just go away? Hello, what can I do for you, Ellie? Yep, there you go. Thank you very much. Appreciate it. I don't I got a good night's sleep last night. I don't know why I'm like falling apart over here. It's like Mr. Peterson, you forgot how to graph. Mr. Peterson, it's like, please thank you though. Please and thank you though. I really do appreciate you guys keeping me honest when I make little mistakes like that. Now, guys, we can actually. This had a center of dilation though. There was a place that this shrink was happening. So when I say teach, I want you to say, okay, talk to your partners. What do you think the center of dilation was? Where was all this change occurring? Teach! You found it?
I did not.
Oh, so if you look up, just go to shared with me, and then just look up field trip.
Okay, here.
And then it's just a file that you and Jane and I have access to. Okay. There it is. Let's do the 8th grade, because the 8th grade is actually pretty well done.
Okay.
So here we go. So for 8th grade, these are all volunteers? All the new 8th grades were?
Yeah, yeah.
Heck yeah. Okay, that's awesome. So volunteers are a little trickier, so we'll just do that one first. I like that. So what we're going to do is you're going to find this person. So it'll be under their last name. So we're going to go find them. Yep. We should just be able to scroll down. Yeah, because it's all alphabetical in here. There, I was just acting really slow. Okay. Yeah, let's go on down to the T's.
Okay.
There it goes. There he is. So his slip is turned in, so you're going to click a check mark right there. And then does he need a lunch? He does not need a lunch, so we don't check the lunch.
Okay.
If he needed a lunch, like let's see if any of these people need a lunch. No. If he needed a lunch, you would put down the check mark on lunch, and then if they put the peanut allergy, you'd put the peanut allergy.
Okay.
And then since he's a volunteer, we're going to click the volunteer button. And then we look on this sheet. If it was Apple, there'd be like a little Apple stamp on here, which I thought, was there one of those in here? Or was it in the...
Yeah, I think I saw one of them in there.
In the 7th grade maybe. So if you see that, you check Apple, and that's something that I have to deal with. So don't worry any further about that. But since he's volunteering, we're going to turn this slip around. You're going to write the volunteer name here. Perfect. And then you're going to write down their email here. And then their phone number on the next one here. Perfect. And then we can just take this sheet. They're all done with that. And then we put it in here, alphabetical by last name. And that's the digitized. Once you get those, we're doing the same thing with the 7th grade. So just put all the 7th grade digitized in that digitized folder. Thank you so much. Perfect. Thanks, Vivian. Okay, can I get you in 5, 4, 3, 2, 1? Let's see here. Where do you guys think the center of this dilation occurred, guys? At what point do you think? Shreyan.
Origin at point A?
Yes, it's at the origin. Very good. And here's the deal. When we're talking about this, we're talking about the scale factor. The scale factor is how many times bigger or how many times smaller it is. So, got a pencil? To dilate a figure centered at the origin by a scale factor of S, use the rule x comma y turns into s times x comma s times y. You just multiply all the coordinates by your scale factor. Yep, sx x, comma sy. Okay. So if I asked you to dilate Lena prime by a scale factor of 3, centered at the origin, you could just multiply all of these coordinates by 3. Are you guys feeling okay about that? You guys feel like that? But what if I asked you to dilate Lena by a scale factor of 3, centered at I prime? So when I say teach, I want you to say, okay, see if you can come up with any ideas of how we might be able to do that. If I asked you to dilate Lena prime by a scale factor of 3, but centered at I prime, do you have any ideas about how we might be able to do that? Take a minute to talk about it, and then we'll look at it together. Teach, teach! Uh, let's get this done first. Let's talk about this first. Perfect. Okay. Yeah. It means either. It could be getting smaller, it could be getting bigger. It depends on the scale factor. Can I get you in 5, 4, 3, 2, 1? Does anyone have any ideas of how we might be able to do that? Yeah, go ahead, Stephen. Sure. So if I've got I prime here, so if it's centered at I prime, you'll notice, guys, will I double prime move away from I? Yes or no? I prime, no. So I double prime is going to be here. Here's what we're going to do, though. If we count all the spaces from I prime to L prime, it goes 1, 2, 3, 4, 5, 6 up, and then left 1. If we multiply both of those by 3, what is 6 times 3? 18. What is 1 times 3? So if we go up 18 and left 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18. I kind of run out of space, but then we're going to go left 1, 2, 3. I've got it right there. Oops, I'm going to change that to blue. Blue. Right there. If you're going to count your way to A, it's 1, 2 to the right, and 1, 2, 3, 4 up. What's 2 times 3? 6. So it would go 1, 2, 3, 4, 5, 6. What's 3 times 3? So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. There's A double prime. Did I do that right? 1, 2, 3. No, 1, 2, 1, 2. Oh, it's 4 up though, isn't it? Yeah. Yep, I miscounted. So it's 4 up. So it would go 1, 2, 3, 4, 5, 6 up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That looks better. I just miscounted. My apologies. There we go. That looks better too. Then from n to n prime, it goes 1, 2, 3, 4, 5, and then up 1, right? 1, 2, 3, 4, 5, and up 1. So it should go right 15, up 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15. Kind of run out of space. I apologize. 1, 2, 3. Needed to have you guys make this bigger. There's n double prime. The rule for that is a nightmare, just so you guys know. The rule for that's a total nightmare. But you can see how to do it with the counting there. Are you guys feeling okay about that? Okay, very good. The other thing you have to worry about, guys, is if I ask you for the scale factor between two figures. So, for example, put your pencils down. I'm just going to show you really quickly. The rule, well, you're welcome to try it. Like, if you look at L prime went to L double prime, which is negative 3, comma, is that, oh, sorry, 1, 2, 3, 4, negative 5, comma, 14. There is a way you can do that, but it's pretty unpleasant, especially because the thing is that somehow we need I prime to land back on itself, right? You need that to turn into negative 2, comma, negative 4, and it's no trick there. It's pretty wild. But go ahead and put your pencils down for a second, guys. I just want to show you. If I had a rectangle like this, and I said I dilated it and rotated it and did a bunch of other stuff so that it looked like this. Let's see, 1, 2, 3, 4, 5, 6. So I need 1, 2, 3, 4, 5, 6, 7, 8. There. If I dilated this rectangle and rotated it and reflected it and did a whole bunch of other stuff, so now it looks like this. If this was the first rectangle and this was the second, when I say teach, I want you to say, okay, how can I have found the scale factor that took me from the little one to the big one? Give it a try and teach. There you go. Okay. Ooh, who was that? I heard somebody saying that. That was great. Can I get you guys in 5, 4, 3, 2, 1? I actually heard that perfectly, guys. I heard someone out there. I don't know if somebody can help me. Who said that? Who said I heard someone say you do the new length divided by the old length. I think I heard that literally said out loud. No? Maybe I heard it in my head. So the scale factor is scale factor. You don't have to write this down. We can just take a look at it. Factor is equal to the new length divided by the old length. And so you could take 1, 2, 3, 4, 5, 6. Is that the new length or the old length, guys? New. And divided by the old length, 1, 2, 3, 4. And that would be 3/2. If it went the other way, if I went from the big one to the small one, the scale factor would just be 2/3. That's the idea. So what I need you guys to be able to do is to be able to dilate things from the origin by multiplying the old coordinates by your scale factor. I need you to be able to dilate from places that are not the origin by counting the spaces and then multiplying those spaces by the amount that we're looking for. I need you to be able to identify the scale factor given two figures that are what we call similar, but we'll get into similarity a little bit more tomorrow. Whew, that's a lot, but that's okay. We got time to practice, guys. So when I say teach, I want you to say, okay, open up your Chromebooks and you can work on 14.5. If you didn't finish 14.4, you're welcome to do that too. But 14.5 is our dilations on the coordinate plane. That's the new stuff. See what you guys can do and teach.